Good morning to all. Up till now, we will complete our first unit, that is spur gear. Some numerical we have solved. I will give some question bank which contain the numerical on a unit 1. You have to try to solve it by your own, and if you have any doubt regarding this, you can ask me anytime. In today's session, we will start with our second unit. In second unit, there are 4 different topics. That is a helical gear, worm and worm wheel, bevel gear. This type of topic in second unit. So in today's session, we will discuss about the helical gear. What is helical gear? What are the advantages, disadvantages of the helical gear? What is the difference between a helical gear and spur gear? What are the terminology of the helical gear? How the force analysis of the helical gear will conduct, what, what are the similarities between a helical gear and the spur gear. Okay, so we will start with helical gear. Is screen visible to all? Okay. Helical gear, in this chapter we will discuss about the terminology of the helical gear and force analysis of the helical gear. Okay, helical gear, if we see, this is the structure of the helical gear. If we see this is the axis of the helical gear, and these are the tooth profile of the helical gear. Okay, and if we see in a helical gear, the teeth of the helical gear are inclined to the some angle to the axis of the gear. Means the if this is the axis of the gear and the direction of the teeth in this way, there is some angle between the axis of the gear and center line of the teeth of the helical gear. Okay, if we see here the teeth and the angle between the axis of the gear and the teeth is called as the helix angle. Okay, helix angle, and it is denoted by the alpha. What is the helical gear? Helical gear is the gear in which there is some angle between axis of the gear and the orientation of the teeth, and this angle is called as the helix angle, and it is denoted by the alpha. Okay, if we see in spur gear, the teeth of the helical gear, I will show you the diagram of spur gear. Okay, this is the spur gear. If we see in this image, the axis of the gear and the teeth are parallel to each other, and if we see in helical gear, the axis and the teeth are not parallel to each other. There is some angle, that is alpha angle, in between them. Due to this, if we see in bevel gear, the contact type of the teeth, if we see in a spur gear, the contact between the teeth of pinion and the gear is a line contact, and throughout the power transmission or a motion transmitter, this contact remain constant. Means if the line contact is like this in a spur gear, at the start of the engagement up to the end of the engagement, these contact is remain constant and it is a line contact. But if we consider the helical gear, in a helical gear, due to the inclination of the teeth in a gear, the at the start of the engagement, the contact is point contact and it will increase up to the end of the engagement, and at the initial it is point contact and at the last it is a line contact. So gradual engagement means at the initial the contact is point contact and at the end the the contact is a line contact. Due to this gradual engagement of the teeth, it reduces the shock and the stresses. Okay, due to the gradual engagement of the teeth. What is the meaning of gradual engagement? At the start of the engagement, the contact is point contact and up to the end of the engagement, the contact is the line contact. This is called as the gradual engagement, and due to this gradual engagement, there is a reduce the shock and the stresses. Means shock and the stresses are reduced in helical gear. Due to this, what happened due to the gradual engagement, more smooth and the quiet operation. Means while transmitting the power or a motion, okay, while transmitting the power and the motion, there is the operation is smooth and the quiet. There is a less noise is generated. If we compare the helical and the spur gear, the operation of the spur gear is noisy as compared to the helical gear. Okay, this is an advantages of the helical gear over a spur gear. Use the high speed transmission. The transmission due to the quiet and the smooth operation, the speed transmission is high. Means high speed is transmitted in a by use of the helical gear. That's why for a high speed operation, helical gear is preferred over a spur gear. This is another advantages of the helical gear. Okay, then the tooth strength is greater because of the teeth are longer. Okay, what is the meaning of this? If I this sorry, suppose this is the width of our gear, means this is a width of our gear, and if we consider this is a spur gear, then the length of the teeth is this straight line. Okay, but if we consider the same as a helical gear, and in helical gear the teeth are inclined, means like this. Okay, okay, suppose I mark this line as a 1 and this line as a 2. If we compare these two lines, 1 and 2, the width of the gear is same, but length of line 1 and line 2, if we compare, the length of line 2 is more than the line 1. Means what? The length, if we consider the helical gear of and spur gear of same width, then the length of the teeth of the gear is more in a helical gear. Okay, due to inclination, the length of the teeth is more in helical gear. That's why great tooth strength is greater. As if we see, as the length of the teeth of the gear is increases, it becomes stronger. That's why the strength of helical gear is more than that of the spur gear. Greater surface contact on a teeth thus carries more load than the spur gear. The contact of there is a contact between the teeth is more in helical gear. That's why it carries a more load than the spur gear. And application, what is the application of this is it is used in automobiles. And generally helical gears are used for a high speed transmission gearbox. Okay, these are generally these helical gears are also used in gas turbine or other high speed applications. These are the some advantages of the helical gear. Okay, if you have any doubt regarding this helical gear, you can ask. कुणाला काही डाउट्स आहे आतापर्यंत जे काही झालं त्याच्यामध्ये? हेलिकल गियर आणि स्पर गिअरचं जे काही कंपॅरिझन सांगितलं त्यामध्ये ओके नाही. नेक्स्ट. हॅलो, हां बोला, कोणाचा काही डाऊट आहे का? The next is the disadvantages of the helical gear. Longer surface of contact reduce the efficiency. Due to the long surface contact is larger in a surface contact is larger in a helical gear. That's why due to this there is a large more friction as compared to spur gear, and due to this there is a reduction in efficiency. There is a reduction in efficiency of helical gear as compared to the spur gear. Okay, they induce the axial thrust in a one direction on a bearing. This is the disadvantages. This is the most important disadvantages of the helical gear, that they induce axial thrust on a bearing. We will see what is the axial thrust in force analysis of the helical gear, but remember that there is more axial thrust in one direction on a bearing due to the helical gear. If we see the orientation of this teeth is inclined to the axis, therefore it is difficult to manufacture. Due to this orientation of the teeth, this is difficult to manufacture as compared to the spur gear, because the direction of or orientation of the teeth in a spur gear is parallel to the axis, but in helical gear the orientation of the teeth is inclined to the axis of the gear. That's why it is difficult to manufacture, and due to difficulty in manufacture it is more expensive as compared to the spur gear. These are the some disadvantages of the helical gear. Okay, लक्षात आलंय what is helical gear, what are the advantages of the helical gear, what are the disadvantages of the helical gear, and what are the application of the helical. कोणाला काही डाउट्स असतील तर यामध्ये विचारा, म्हणजे क्लिअर करता येईल, नाही तर मला नेक्स्ट पॉइंटला मूव्ह व्हायला. ओके, herringbone gear. Sorry, I have left one point here, that is the orientation of the, suppose I consider this is a pinion, because we call the small part as a pinion, and this is the gear. The hands, this orientation is called the hand of the gear. If the inclination of the teeth is towards the right, then it is called a right-handed gear, and if orientation of the gear towards the left hand, then it is called as a left hand gear. Okay, if orientation is towards the right hand, then it is called as the right hand gear, and orientation of the teeth is towards the left, then it is called as a left handed gear. And while engaging, means when if we give the input to the pinion and pinion is right-handed, then gear must be left-handed. Means if gear is left-handed, then pinion must be a right-handed. Vice versa. Okay, if gear is left-handed, then pinion should be a gear is a left-handed, then pinion should be a right-handed, or if pinion is left-handed, then gear should be a right-handed. This is the most important while designing of the helical gear. Okay. Then herringbone gear. It is similar to that of the helical gear. Two helical gears of identical pitch of opposite hand. Means if we connect two these two helical gear face to face, then it is called as the herringbone gear. Only difference is that one part is left-handed, then other part must be a right-handed. Okay. There is one doubt that explain right hand and left hand gear. Okay. 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 See here, what is the left-handed and right-handed gears? I will explain it one again. If we see this pinion, the orientation of these teeth is from left to right. म्हणजे हा जो काही पिनियन आहे हा लेफ्ट साइड राइट साइडला वरती मूव्ह होतोय. ओके, म्हणजे याचा जो काही स्लोप आहे हा लेफ्ट कडून राइट साइडला वरती जातोय, तर याला राइट हँडेड गियर म्हणतात. ओके, इफ द स्लोप ऑफ द टीथ इज increase from left to right, then it is called as the right handed. And if we see this gear, it is from left to right, means at the left it is at upper position and it is at right it is at the lower position. Therefore this gear is at the left handed. Okay, left handed, and this is right handed. आलंय लक्षात? लेफ्ट हँडेड आणि राईट हँड मधला डिफरन्स कळलाय? ओके. Next is a herringbone gear. If we connect two helical gear of different hand, means this is a gear 1 and this is a gear 2, and if we connect this side by side, but orientation of the gear 1 is right handed and orientation of the gear 2 is left handed, and if we connect these together, then it is called as a herringbone gear. Okay, means this is a one gear. This combination is togetherly called as the one gear. Here similarly, this is a, suppose we see this image, this is a pinion, this is a gear, but pinion is made up of the two gears which is connected by face to face and side by side, and their orientation is opposite. While explaining the disadvantages of the helical gear, I explained that they induce axial thrust. In a case of helical gear, they induce the axial thrust in a one direction on the bearing. These disadvantages is removed or these disadvantages is not remain in a herringbone gear because of two axis or two helical gear are connected here. That's why the axial thrust of the two gears acts in an opposite direction, and that's why problem of axial thrust is eliminated. ओके, म्हणजे हे दोन गिअर साइड बाय साइड जॉईन केल्यामुळे जो ऍक्सियल थ्रस्ट जनरेट होता हेलिकल गिअर मध्ये तो इथं रिड्यूस होतो आणि तो झिरो होतो इन हेरिंगबोन गिअर. दिस इज अन ऍडव्हान्टेजेस ऑफ द हेरिंगबोन गिअर. ओके, नाउ next term is terminology of the helical gear. Some terminology we have seen in spur gear. We will not explain this terminology here. We will explain which are different terminology used in a helical gear instead of the spur gear. See here, if we see this diagram, there is a sectional view at NN. Means here we take a section view of helical gear in normal plane. In upper side there is a normal plane. Sectional view at NN means at a normal plane. Okay, if we see here the sectional view at normal NN means that if we cut this bevel gear in normal plane. What is a normal plane? The plane which is perpendicular to the direction of the teeth is called as a normal plane. And transverse plane is the plane in which which is perpendicular or which is parallel to the axis of the gear. Okay, means the gear along the axis of the gear कट केला, जर मी गियर अलॉंग द ऍक्सिस कट केला तर मला ट्रान्सवर्स प्लेन मिळते, आणि जर मी गियर परपेंडिक्युलर टू द टीथ जर कट केला तर मला नॉर्मल प्लेन मिळते. इथं नॉर्मल प्लेन म्हटलंय, इथं हा जो काही अल्फा आहे हा आहे हेलिक्स अँगल. पीएन बघूया आपण काय. पीएन इज द pitch of normal pitch. PN for P for pitch and N for normal pitch, and PT is the transverse pitch. Okay, we will see one by one. इथे एंड ला सेक्शन व्ह्यू ऍट TT दाखवलाय. ओके, म्हणजे सेक्शनल व्ह्यू ऍट ट्रान्सवर्स प्लेन. ओके, बघूया आपण काय आहे ते सर्व. ओके, हेलिक्स अँगल. व्हॉट इज हेलिक्स अँगल? सुरुवातीलाच मी एक्सप्लेन केलं. इट इज अँगल बिटवीन ऍक्सिस ऑफ द शाफ्ट अँड सेंटर लाईन ऑफ द टीथ. Axis of the shaft and center line of the teeth. It is the angle at which teeth are inclined to the axis of the gear. At which angle teeth are inclined to the axis of the gear is called as the helix angle, and it is always denoted by the alpha. Then transverse circular pitch. First of all, we will discuss what is a pitch. What is a pitch? Pitch is the distance between a two adjacent teeth. Okay, if we take a 1 point on a teeth and we will take the same point on a next teeth, then this distance between these two teeth is called as the pitch. But in terms of gear, we will measure this distance along a pitch circle. Means it is a distance between the two adjacent teeth of same point when it is measured along a pitch circle. Then what is the transverse pitch? Transverse pitch, it is the distance between corresponding point on an adjacent teeth measured along a PC means pitch circle in transverse plane. Transverse plane मध्ये जर आपण दोन टीथ मधल्या सेम पॉइंट्स वरचं डिस्टन्स मेजर केलं तर त्याला म्हणतात ट्रान्सव्हर्स पिच आणि ते डिनोटेड केलं जातं ट्रान्सव्हर्स पिच आणि इट इज डिनोटेड बाय द पी सफिक्स टी. ओके, दिस इज डिनोटेड बाय द पी सफिक्स टी. दिस इज द one terminology in transverse pitch. Then next one is a normal pitch. It is similar to that of the transverse pitch, only it is distance measured along a normal pitch. It is a distance between corresponding point on an adjacent teeth measured along a pitch circle in normal plane. Okay, I will explain here in this diagram. इथे फक्त थोडंसं लक्ष द्या व्यवस्थित. हा जो काही व्ह्यू हा सेक्शनल व्ह्यू ॲट अ नॉर्मल आहे, नॉर्मल प्लेन आहे. देअर फोर द डिस्टन्स ह्या पॉइंट पासून तर ह्या पॉइंट पर्यंतचं जे काही डिस्टन्स आहे तर त्याला म्हणतात नॉर्मल पिच. ओके, नॉर्मल पिच. आणि ट्रान्सफर हा जो काही सेक्शन आहे, सेक्शन आहे टी टी, तर हा आणि हा जो काही पॉइंट आहे यांच्यामधला किंवा हे दोन पॉइंट कन्सिडर केले एवढं डिस्टन्स, तर हे आहे ट्रान्सवर्स पिच. लक्षात ठेवा हे डिस्टन्स सेम नाहीये, हे जे काही डिस्टन्स आहे हे डिफरंट आहे. ट्रान्सवर्स पिच अँड नॉर्मल पिच हे वेगवेगळे डिस्टन्स आहेत. ओके, normal pitch, it is a distance between corresponding point on an adjacent teeth measured along a pitch circle in a normal plane. It is denoted by the Pn. And where Pn, इथे हे इक्वेशन आहे बघा. इथे जर मी हा ट्रायंगल कन्सिडर केला, हा जो काही ट्रायंगल आहे याच्यामध्ये, आणि याच्यामध्ये मी जर लिहिलं कॉस अल्फा इज इक्वल टू हिअर इज राईट अँगल 90 degree, therefore PT is acts as a hypotenuse, and for cos adjacent side upon hypotenuse, adjacent side is PN, where PN is the normal pitch and hypotenuse is PT, therefore cos alpha is equal to PN divided by PT, and Pn is equal to Pt into cos of alpha. Okay, this is the relation between transverse pitch and normal pitch. Okay, always remember that transverse pitch is always has more value than the normal pitch. म्हणजे ट्रान्सफर पिच आहे त्याची जी काही डिस्टन्स आहे ते जास्त आहे नॉर्मल पिच पेक्षा. बट वी नो दॅट pitch is equal to pi into m. What is m? M is the module, and if we put this value pitch is equal to pi into m, we will get the relation that m suffix n. M suffix n is the normal module. M for module and n for normal. Okay, therefore relation between normal module and transverse module is mn is equal to mt into cos of alpha. Okay, this is the relation between normal module and transverse module. The next terminology is a transverse pressure angle. We know that pressure angle is measured in pressure angle is denoted by the phi. Transverse pressure angle, the pressure angle measured along a transverse plane, means the angle measured in a pressure angle measured in a transverse plane is called as transverse pressure angle, and it is denoted by the phi t. Normal pressure angle is the angle measured along a normal plane, which is denoted by the phi n, and relation between normal pressure angle and transverse pressure angle is denoted by cos alpha is equal to tan phi n divided by tan phi t. Alpha is the helix angle. Okay, this is a Then next terminology is center distance. What is a center distance? It is a distance between axis of the two meshing helical gear. म्हणजे दोन ऍक्सिस जे काय हेलिकल गिअरचे त्यामधलं डिस्टन्स म्हणजे सेंटर डिस्टन्स आहे. आणि ऑलवेज रिमेंबर दॅट इन हेलिक्स गिअर इज यूज मीन्स इफ यू क्लासिफाइड द हेलिकल गिअर आर अ parallel axis shaft. Parallel axis gear means axis of the helical gear are parallel to each other. भले त्यांचे जे काही टीपचं ओरिएंटेशन आहे हे इन्क्लाइन असेल, पण त्यांचे जे काही ऍक्सिस आहेत गिअरचे ते पॅरलल असतात एकमेकांना. ओके, देन सेंटर डिस्टन्स आय विल एनलार्ज दिस इमेज सो यू विल बेटर नो. सेंटर डिस्टन्स, व्हॉट इज अ सेंटर डिस्टन्स? जर दोन सेंटर मधलं मला दोन सर्कल मधलं सेंटर, सपोज आय विल राईट हिअर, इफ दिस इज अ सर्कल 1 and this is a circle 2 and I want to calculate the distance between these two centers, then what is the center distance is this radius plus this radius. If we take the summation of these two radius, then we will get the center distance. Here we similarly denoted that center distance is equal to small d plus capital D by 2. Small d is the pitch circle diameter of the pinion, capital D is the pitch circle diameter of the gear, and divide by 2. Why? Because of we want the radius of these two gears, therefore capital D plus small d by 2. This is the center distance. Okay, then diameter is denoted in terms of module and number of teeth, where here if we see here small d is equal to m into z. What is m? Here we have take that mt. Mt means transverse module and z suffix p means number of. ओके, डिस्कनेक्ट झाली होती हे मी परत एकदा कनेक्ट करतो आणि एक्सप्लेन करतो. ओके, m into z. Z is a number of teeth, p for a pinion and g for a gear, and mt is the transverse module. Okay, mt is here transverse module, therefore center distance is equal to mt into zp plus mt into zg divided by 2. We will take mt as a common, then center distance is equal to mt. इथे जर बघितलं तर सेंटर डिस्टन्स इज इक्वल टू mt by 2 into zp plus zg. Okay, this is its formula for center distance of the helical gear, where mt is the transverse module. Or if we write this equation in terms of normal module, then center distance is equal to normal module divided by 2 into cos of alpha into zp plus zc, where alpha is the helix angle. Okay, this is the formula for center distance. In university exam, this question is asked for 3 marks. Derive the equation for a center distance between two helical gear in terms of transverse module and in terms of normal module, which is asked for 3 marks. Therefore, remember this formula. Okay. Now we will discuss about the gear ratio or velocity ratio. What is the gear ratio? The ratio of number of teeth on a gear to the number of teeth on a pinion. The number of teeth gear वर किती आहेत divided by number of teeth on a pinion. Here we write that G is equal to ZG divided by ZP. ZG divided by ZP, or G is equal to MT into D divided by mt into small d, and therefore G is equal to capital D by small d, the diameter of the gear to the diameter of the pinion. This is another formula for the gear ratio or velocity ratio. What is the velocity ratio? It is a ratio of speed of the driver. Always remember the speed of the pinion is always more. जर आपण पिनियन जर घेतला तर पिनियनची जी काही साईज आहे ती छोटी असल्यामुळे पिनियनचा स्पीड हा जास्त असतो. Okay, therefore it is a ratio of speed of the pinion to the speed of the gear, and therefore np divided by ng is the formula for velocity ratio. These three formulas are for a gear ratio or a velocity ratio. This derivation or this definition plus these formulas are asked for a 3 marks in university exam. Therefore concentrate here center distance and velocity ratio. Okay, these are the formulas or these are the some terminology which is related to the helical gear. Okay, if you have any doubt regarding this, you can ask. तुमचे काही डाउट्स असतील याच्या रिगार्डिंग तर ते विचारा. जे काही आज बघितलं, व्हॉट इज हेलिकल गिअर, व्हॉट आर ऍडव्हान्टेजेस, डिसएडव्हान्टेजेस, ऍप्लिकेशन ऑफ द हेलिकल गिअर अँड some terminology of the helical gear. We have discussed this part today. So you have any doubts regarding this, you can ask in a comment section also. नाही काही डाउट्स? ओके, मी अटेंडन्स लिंक शेअर करतो. अटेंडन्स हे करा, मार्क करा.